Okay, so we're going to continue our discussion on the interconnectedness of the Earth's systems by looking at the first of the biogeochemical systems, the carbon cycle. So, by the end of this lesson, you should be able to explain the steps and reservoir interactions in the carbon cycle. So to do this, we're going to identify the major reservoirs for carbon. We're going to describe the path that carbon takes through the long-term and the short-term carbon cycle, and describe how humans can impact the carbon cycle. So here's our carbon cycle. So I've shown you two different pictures because we have a long-term and a short-term cycle. So some reservoirs, so reservoirs are the stages that hold carbon, can hold carbon for long times. So this would be as it moves through the geological cycle. This is the black and white picture right here. And some carbon reservoirs can hold carbon for just a short amount of time. And this would be our biotic cycle of animals and plants. So let's start by talking about how carbon moves through the geologic cycle. So we're mostly familiar that there's a lot of carbon dioxide in the air, but it gets there in the geologic cycle from volcanic eruptions. So if we start over here, we see that the CO2 is being pushed up and out by the volcanic eruption and then moves to our atmosphere. Our atmosphere is one of the reservoirs for carbon dioxide. And so some of this carbon dioxide dissolves into the ocean, and it can go into and out of solution at the surface of the ocean, but as it filters down further into the ocean, it gets incorporated into the shells of marine organisms to make calcium carbonate, CaCO3. And this helps form their shells. And that calcium stays in their shells until they die, and that shell then can get compressed into limestone in the ocean. So we're down here getting compressed back into limestone. Then we've got subduction, those get pushed back underground, converted into magma, spewed out again in these volcanic eruptions. So there's a small portion of that biogeochemical cycle for carbon. So the geologic cycle goes through the subduction, back to the volcano, back into the atmosphere, and so on and so forth. Now, the way we interact with carbon dioxide most often is through photosynthesis and respiration. So our short-term cycle is that animals exhale carbon dioxide, that's respiration, and then plants through photosynthesis take that carbon dioxide in and then store that in their tissues. And that will stay there until they decay, and that carbon will go down into the decomposers and then back into the soil. Or if animals die and their bodies get broken down over time, those get turned into fossil fuels. Then those fossil fuels get turned into gas, oil, coal, and get turned back into the atmosphere. Additionally, we can have the carbon in the soils get compressed down into limestone, and then that can eventually get broken out through weathering and then pushed back into our ocean or back into the soils. So it's important to know where carbon is stored. So there are four main reservoirs of carbon. The largest one is the crust. So we have a lot of carbon containing sediments and rocks, such as limestone or fossil fuels. The next largest is the ocean. So that can be found in plants, in the calcium carbonate in the shells and the limestone. After that, we also hold carbon, so we store carbon in the soils and vegetation, so in the bodies of plants and animals, in the soil, microorganisms, and last, the smallest reservoir is atmosphere, as carbon dioxide gas. So these are what we call carbon sinks. They hold carbon for a certain length of time, as opposed to carbon sources, which is what allows the carbon to move between these different reservoirs. So even within these reservoirs, they may hold carbon for different lengths of time. So if you think about what we learned about with the terrestrial biomes, we see that the tundra has the slowest turnover, so it holds carbon for a longer time than the tropical rainforests do. So how can humans impact the carbon cycle? So I want to draw your attention, this is the processes. So we've got the arrows are our carbon sources, and we've got our sinks. So within vegetation, carbon is moving in and out through photosynthesis and respiration. And you can see those are fairly balanced. So the amount going out is the same as the amount coming in. Over in our ocean, it's the same way. So there's just some gas exchange at the ocean with carbon dioxide dissolving in and out of the water. Pretty balanced, right? What's going in, pretty equal to what's going out. Not a big overall change. But what you notice here is that net land use change, so burning trees, thawing permafrost, and also the burning of fossil fuels is adding a lot of carbon dioxide back into the atmosphere, which is not mirrored by the same process taking it out. So this is a one way. There's no process which is equal to it taking the same amount of carbon back out. So this is what's leading to a disruption in our overall carbon cycle. So to summarize, we learned that carbon moves through a long-term and a short-term cycle. So our long-term is through the abiotic portions, such as the fossil fuels, the sedimentary rock, the atmosphere, volcanoes. And then the short-term cycle goes through our biotic portions, photosynthesis, respiration, and decomposition.